Welcome to Circular Economy Modeling module. In this unit, we will look at case studies to provide concrete perspectives on circular economy modeling for a sustainable textile industry. In doing so, we will dwell into the following Horizon Europe projects. Let's start with Plastis project. Plastis project. Closing the loop in the plastic life cycle. Recycling is necessary to overcome the challenges of climate change. Unfortunately, only 20% of plastics produced are recycled. This is mainly due to difficulties in the recycling process that include the presence of contaminants or other mixes in plastic waste. This leads to large amounts of plastic waste being incinerated or landfilled, causing serious environmental impacts. The EU-funded Plastis project aims to tackle this issue. It aims to develop and design 4 innovative technologies: cascade enzymatic hydrolysis, combined gasification and chemical post-treatment, hydrothermal liquefaction, and microwave-assisted pyrolysis, to assess the valorization processes. This will help bring about a sustainable closed-loop value chain for plastic. Recycling project. Plastics. Recycling from and for home appliances, toys, and textile. Innovative solution measuring recycled plastics in products. The EU's plastics strategy highlights the need for accurate measurement and reporting of recycled content in products. However, measuring recycled content is a complex task. To address this, the EU-funded Precycling project aims to create a user-friendly methodology for sorting, sampling, tracing, and recycling plastic waste streams. This includes detecting and separating legacy additives, as well as standard analysis procedures for plastic waste and recyclates. The project will also develop smart tracing through digital systems to ensure the safety and quality of reused materials. Precycling will conduct a life cycle and cost analysis to assess the environmental and financial viability of their solutions. It will demonstrate the methodology by producing home appliance components, toys, learning resources, and 100% recycled textiles. TREX Textile Recycling Excellence Project. The global consumption of textiles is increasing, with global production of the 2 most relevant fibers, cotton and polyester, expected to grow by 40% before 2023. There is also no EU-wide plan on how to deal with the existing and anticipated textile waste. Currently, less than 1% of the material used to produce clothing is recycled into new clothing in a closed-loop process, while 87% is landfilled or incinerated. Based on estimates from experts, we see that 1% of textile waste entering closed loops leads to €100 market loss each year. If a 30% recycling rate is reached, similar to average plastic packaging recycling rates, we will be able to valorize a €30 billion year market. The ambition of T-Rex is to contribute to a paradigm shift from household textile waste into desired feedstock. Moreover, we aim to demonstrate that this new commodity and the business models based on it can be completely implemented within the EU. Demonstration and launch of high-performance, biodegradable, regenerated new cotton textiles to consumer markets through an innovative, circular supply chain using infinited fiber technology. New cotton project. Textile waste transformation into new fibers. The textile industry is among the most polluting industries, generating 1.2 billion tons of CO2 per year, since huge quantities of textile waste are landfilled or burned. However, existing solutions cannot resolve the problem, and there is a lack of feasible alternatives in the market. As the production of textiles is expected to rise by 63% by 2030, the textile industry has agreed with government institutions, environmental organizations, and consumers to move towards sustainable production and consumption. The EU-funded New Cotton Project proposes a cellulose carbamate technology to allow the transformation of textile waste into cost-efficient, cotton-like fiber with superior qualities. The technology can process cotton-rich textile waste, including mixed fibers and other cellulose-based waste feedstocks, into new fibers and textiles. Bio-based local sustainable circularware, which focuses on bio-based materials for locally manufactured, sustainable, and circular clothing. Hereware Project. The EU-funded Hereware project will contribute to the creation of the EU market for locally produced circular textiles and clothing made from bio-based resources. Emerging sustainable technologies for wet and melt spinning of cellulose from waste streams and bio-based polyesters will be developed and piloted at a semi-industrial scale. Hereware will also work on yarn and fabric production, as well as coding and coloring with bio-based agents. Further, the project aims to significantly reduce the release of microfibers via measures for the textile manufacturing process and maximize the sustainability and circularity of clothing through connecting regional microfactories. Guidelines and a database will be provided to support the design of fashion goods, with focus on bio-based materials and reuse, recycling. Finally, garment prototypes will demonstrate the Hereware circular bio-based concept. CIRT Project System, Circularity and Innovative Recycling of Textiles. Project a greener afterlife for your old clothes. The future of the textiles industry is green and circular. Currently, less than 1% of textile waste is recycled into new textile fibers. To reverse this trend, the EU will mandate separate collection of discarded textiles by 2025. The EU-funded SCIRT project will develop solutions for the increasing volumes of collected textiles. It will support systemic innovation towards a more circular fashion system and bridge the current supply-demand gap for recycled textile fibers. CIRT will demonstrate an entire textile-to-textile recycling system for post-consumer textiles, focusing on the recycling of natural and synthetic fibers, as well as fiber blends. CIRT aims to enable conditions and supporting measures to facilitate this transition, giving special attention to the consumer perspective. Sustain-TEX, Circular and Sustainable Textiles and Clothing Project. Increasing circularity and sustainability in textiles and clothing in Europe. The production and consumption of textile products continue to grow, together with their impact on the environment, due to a lack of reuse, repair, and recycling of materials. The EU-funded Sustain-TEX project aims to increase textile circularity in Europe through a holistic approach enabling circular material flows. It will develop innovative, sustainable, inclusive, large-scale value chains in the reuse, repair, and recycling of materials. The feasibility will be demonstrated by 3 pilots: repair and disassembly, sorting for reuse and recycling, and circular garments by fiber-to-fiber recycling. Sustain-TEX project, a new circular economy concept. From textile waste towards chemical and textile industries feedstock, the project aims at designing, developing, and demonstrating new high environmental impact industrial symbiosis between the unwearable blends and pure components of textile waste and the chemical and textile industries. The project comprises a strategic design of the whole value chain from textile waste collection until the new marketable feedstock for chemical and textile industry, by which the symbiosis opportunities are evaluated by public authorities and the private sector in terms of their social, technical, economic, environmental, and legislative aspects. Decode, recycling of coated and painted textile and plastic materials. Project smart additives to give new life to coatings that are difficult to recycle. The majority of textiles and plastics with coatings, from clothing and electronic devices to automotive parts, ends up in landfills. The goal is to reverse this trend and meet ambitious plastic recycling targets of 50%, set by the European plastics industry. But many materials consist of more than one chemical component, making them non-recyclable unless these components are separated. The EU-funded Decode project will develop a solution to ensure the circular use of textiles and plastic parts with multi-layer coatings. Specifically, it will investigate triggerable smart polymer material systems and appropriate recycling processes. The triggerable solutions will be based on smart additives like microcapsules or microwave-triggered additives. The new Decode principle will be demonstrated at a recycling pilot plant. FIBFAB project, industrialization of bio-based textile fabrics for clothing applications. Main FIBFAB project innovations are to obtain a final clothing product 100% bio-based and biodegradable that meets the mechanical and performance requirements of the textile sector, to improve the current poor thermal resistance of PLA fibers to meet the requirements in several clothing applications by adding additives to enhance the final PLA crystallinity, to improve the extrusion process for PLA fibers, and especially the mechanical spinning process, reinventing a smart, circular, and competitive textile industry with advanced mycofibers fungi for fashion answer call for eco-friendly fabrics. The mycelium is the vegetative part of a fungus consisting of long, thread-like interwoven structures. Such networks of fungal threads are remarkable. In fact, mycelia can be used to develop innovative products for several industries, ranging from pack-egg-ing to textile. This is particularly good news for the fashion industry, where sustainable and biodegradable textiles are a welcome addition to the modern, fast fashion wardrobe. The EU-funded MyFi project will develop a new non-woven fabric made of mycelium microfibers, with improved performance and reduced environmental impact in comparison to current commercially available fibers. The project will optimize and upscale new biofabrication protocols together with wet processing and material finishing. Its goal is to meet consumer demand for sustainable and eco-friendly textile products. Circular solutions for the textile industry, sustainable clothing and fishing gear. The EU-funded Glaukos project aims to develop innovative and environmentally sustainable textile fibers and coatings. The complete life cycle of these textiles will be redesigned. Their sustainability performance, i.e. biodegradability and biorecyclability, will be enhanced significantly, while their technical performance will be matched to end-user requirements. Glaukos builds on two concepts: triggerable biodegradability as a key concept in polymer design to mitigate textile-based microplastics pollution, and biorecycling as a sustainable end-of-life solution. The supply chain distance is also substantially reduced by scaling up a disruptive way of producing the main polymer building block from several bio-based feedstocks. The underlying objective of Glaukos is to reduce the carbon and the plastic footprint of clothing and fishing gear. Stakeholders' engagement will be encouraged through the involvement of individuals from the clothing and fishing gear industry. Here are the references. Thank you for your attention.